This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and my guest is David Purpura, who's an assistant professor of human development and family studies at Purdue University. David, thanks for being here.
Thanks for having me, Sam.
We're going to be discussing David's article that's in the current issue of the American Educational Research Journal, and the article is entitled Informal Numeracy Skills, the Structure and Relations Among Numbering, Relations, and Arithmetic Operations in Preschool. But before we get to the article, I wanted to back up and allow David to tell us about his graduate school experience and his path leading him to math education.
Okay, Sam. I actually went to Florida State University for grad school, where I got my PhD in clinical psychology. I worked with Chris Lonergan, who's actually an early reading researcher. And originally, my research interests were early behavior and early reading skills, but over time, I slowly moved into early math skills. To a degree, I've always been interested in math. I was actually a math major in college at one point.
Okay.
I ended up majoring in psychology because I wanted to do more applied work. And so when I first went to grad school, my primary focus working with Chris Lonergan was early reading skills. But as I was working to find my niche in reading research, I started reading some articles in early math and decided that was really the area that I wanted to start studying. The switch actually came right before I started developing my dissertation. So it was kind of a big switch before a big project. But at first I was thinking about doing an intervention study on early number sense, but the more that I started reading and working to define what it was that I actually wanted to do the intervention on, the more I realized that there really needed to be better definitions of what early number sense was.
Mm-hmm. So you felt there was some real intellectual work that had to take place before you could really do an effective intervention.
Right. As I was reading through all these different research articles, a lot of the different articles had different definitions or were talking about the same skills or same concepts, but using different terminology. Mm-hmm. And then I ended up reading Daniel Birch's 2005 paper. It's Making Sense of Number Sense. And one of the issues that he talked about was how there are over 30 different definitions. There are actually over 30 common definitions of number sense. And that's really when I realized that I couldn't do an intervention study unless I knew exactly what it was that I was going to intervene on. And so I started to look at what are early math skills? What are the specific skills and specific domains, and how are these skills related to one another?
Mm-hmm. And the area and the terminology that you set the AERJ article up in is informal numeracy. And so by informal numeracy, you mean a specific thing. In particular, you talk about three components of informal numeracy. So I was wondering if you could just describe for us those components. So there's numbering, there's relations, and then there's the arithmetic operations.
Right. These early numeracy or informal numeracy skills are those skills that kids typically develop before formal schooling. So really before kindergarten. So, like you said, there are the three domains. Numbering, some people will refer to it as counting, but because of a couple of the skills and concepts that are involved in this, I felt like counting wasn't the ideal term. And what I mean by numbering is the ability to determine the total number of items in a set, either by immediately recognizing it or by counting the set. And this also involves understanding the counting sequence. So because it involves skills like subitizing, which doesn't actually involve specific one-to-one counting, I felt like numbering was a better term for that.
Okay.
And then relation skills, that involves understanding how two or more collections or numerals are related, different comparison in skills, and understanding how numbers relate on the mental number line. And then the third area was arithmetic operations, and this is basically children's early arithmetic operational skills, being able to add and subtract quantities without using actual formal combinations.
Okay, and these three domains you drew on the National Research Council's report from 2009, I believe, if I'm remembering correctly.
Correct.
And so that one, you talk about people have been theorizing with these domains, but you're trying to now kind of move towards operationalizing those domains.
Right. One of the big issues that I saw was that two of the main organizations that lay out what those early math skills are actually had different conceptualizations of the organization of the skills. Like the National Council of Teachers of Mathematics, in their standards, they represented it as a two-factor model, where the numbering and relation skills were grouped into one factor, and arithmetic operations was a separate factor.
Mm-hmm. And they call it number and operations, which is,
right.
I mean, just that phrase, number and operations, is very prevalent in NCTM and amongst a lot of math teachers as the way to think about all of these things.
Right, and like you said, the National Research Council, they had grouped it into three distinct categories: numbering, relations, and arithmetic operations.
What did you see as the work that you needed to do in order to be able to really, engage with these in a scholarly way?
Well, looking towards interventions, I thought it was really important that we have a clear and grounded understanding of what these skills are, how they relate to one another, and use that as a foundation for other work. So in order to do any type of intervention or any type of work understanding how these skills developed, I felt that it was really important to first understand what that early factor structure was, or how these skills relate to one another.
Mm-hmm. So I'm going to get you to talk a little bit more about what you specifically did in the AERJ study, which comes from your dissertation work. But building right off this idea of operationalizing, so in your dissertation you developed a test called the PENS test. I was wondering if you could maybe start by telling us a little bit about that test and how it's set up.
Sure. One of the questions that I had for myself after I conceptualized the factor structure analysis was, what am I going to use to assess all of these different domains? And I had looked across a lot of the common early math assessment measures, and most of them used either just a couple items from each of the different domains, from each of the different specific skills within domains, or they didn't actually assess certain skills. So I felt like I needed to develop a measure that actually had all these different components in it. So this was actually, I first identified which of the skills that are assessed on which measures. How can I create individual subscales that actually reasonably assess each of these different domains? And it was a relatively long process of modifying the different instructions and selecting the different items for each of the subscales. But it was done in the same context as the overall study, using the same participants.
Okay. And just for the record, what does the PENS stand for, P-E-N-S?
The Preschool Early Numeracy Skills Test.
Okay. And so it has the three subdomains of numbering, relations, and arithmetic operations, and then you have actually, I think it was, 6, 7, 8, sometimes maybe 9, I can't remember, items per subdomain.
Numbering and relations both had 9, and arithmetic operations had 7.
Okay, as opposed to previous measures, which maybe had 2 or 3, or not really enough items to be able to do certain things that you need to do with those measures.
Right. A lot of the other measures, what they would typically have would be a couple items from across several of the different skills, but not enough to really measure the skill as a whole across a broad range of ability.
Okay. So then, who did you have taking the test, and what was the data that you gathered for this study?
Well, I collected data on almost 400 preschool children ages about 3 to 5. They were from the North Florida area, because I was in grad school at Florida State at the time. And I had 2 different main locations, some in Tallahassee and some in a couple nearby towns. But it was about equally split between boys and girls, and about 56% white, and about 34% African American, and about 10.5% of children from other races and ethnicities, or ones who we didn't have reported demographics for.
Okay.
And the children also came from a wide range of schools. We had about a quarter of the children from Head Starts, and some of the other children came from other low-income preschools, and the remaining schools were a range of private, church-affiliated preschools, or just local community preschools.
Okay. And just to help us, build this image. So, I mean, what did the environment actually look like for the testing? I mean, was there some paper and pencil? Was there some that was like a physical task? What did it look like when the kids were actually doing this?
Well, it depended on which of the tasks that we were using, but typically there was either myself or one of the project staff who were working with me would sit one-on-one with a child, ideally in a quiet location at the school. Not all schools have quiet locations, so it was in whatever was the best option for us.
Mm-hmm.
And some of the questions involved the children using blocks. For example, one of the cardinality tasks asked children, give me n blocks, and so they had to identify how many was n and pull that number out of the larger pile of blocks. And so some had blocks, some had small discs that we used, and others were verbal questions. Others, we used our testing binder that had, for example, the numeral comparison task. Children were shown 4 different numerals and asked which of these numerals means the most.
Mm-hmm.
So there were a wide range of different types of testing environments that the children had.
Okay. So you had these nearly 400 preschool students go through the PENS test with the subdomains. So then in terms of your results, I mean, you have kind of a variety of results to report. First of all, you're going to try to work to verify or check whether those 3 domains held together in terms of the tasks that you designed, whether they held together as an actual, conceptual group. And then you also compared your 3-factor model of numbering, relations, and operations, and you compared that to some other models. But first, if you could just describe to us what you found when you did look at your subdomains and the tasks that you had designed for those 3 subdomains.
Sure. So in order to be able to do the larger study of comparing the different factor structures, I first had to ensure that each of those individual factors held together as its own factor. So what I was looking to do was see if each of those individual tasks fit within their respective constructs. So did all of the numbering tasks fit well together? And what I found was that for the way that I had initially conceptualized it was fairly accurate, and all the tasks that I had proposed within each of the different domains really did fit well within the respective domain.
But there was correlation between the different domains. So you have tasks that were numbering tasks, tasks that were relations tasks, and arithmetic operations tasks. But there also were, I would imagine, strong correlations between the domains as well, right?
Right. There were strong correlations across the different domains. That was something that I did look at, and I looked to see if there were, if any of the skills loaded better on other domains. And generally, what I found was that the domain that I initially put them on was the best location for them to be.
Okay. So then, I believe you were going to move on to comparing the models.
Right. So then, once I was able to verify that each of those individual factors held together well, then I was able to set myself up for evaluating, comparing the different model structures. And so what I did was I compared the three-factor model where each of those domains was distinct to 4 different 2-factor models and a 1-factor model. And the 3-factor model was the one that was based off of the National Research Council's model, and then the different 2-factor models were ones suggested by other research literature. And what I found was that in general all of the models fit the data fairly well, but the 3-factor model actually fit the best. But interestingly, across the 3 domains, all 3 domains were pretty highly correlated, but still distinct.
So you found the 3-factor model as the best fit, but I'm curious, was part of the reason that it was the best fit because it had more factors than the 2-factor models or the 1-factor model, or is it something inherent to the conceptualization of the 3-factor model?
Well, in looking at the model structure, there are a couple things to pay attention to. First is the theoretical development of the model structure. There actually, in the research literature, there isn't a reasonable 4-factor model that was suggested. And then also, yes, a 4 or 5 or 6 or 25-factor model technically would probably fit marginally better, but the issue that you'd be looking at is, does it fit statistically significantly better? And so generally, if you were to go into higher factor models, There would be marginal differences between them if you were to create a four-factor model, but you'd be looking at whether or not the four-factor model would statistically fit better than the three-factor model. There might be marginal differences, but I guess given that there isn't a plausible four-factor model suggested in the research literature, it's not really something that's necessary to evaluate at this point.
Mm-hmm. So we want to use Occam's razor here and basically say there's no reason to go to more factors, if it doesn't give a very noticeable, statistically significantly better fit. Now, with the three factors, which is more than the two factors, you did get a significantly better fit where it was worth it to go to the three factors, is what you're saying?
Right. I mean, the two and the one-factor models did fit the data fairly well. It's just that the three-factor fit significantly better.
So with this article, you set out to really explore and operationalize what you're calling informal numeracy and really try to pin down what that means and also have a measure for that concept. But what do you see as the kind of takeaway point from this article? Or how is this article leading you in your future work?
Really what I see is one of the most important things for any research that we're doing is that we need to have clear and consistent definitions and terminology in our research. Without that, it's really difficult to synthesize the literature and to really develop a cohesive theoretical framework around what we want to do. In order to understand how different skills and concepts develop over time, we have to understand what it is that we're measuring at that initial time frame. And so that was really the goal that I set out, and it's also the foundation of the work that I'm getting into right now and understanding how these mathematical domains develop over time.
Mm-hmm. And do you have future work planned building on this foundation that you've laid?
Yeah, absolutely. Some of the work that I'm conducting right now is looking to understand how these skills interact in their development over time and how other factors, such as non-mathematical factors like language, impact the development of these skills over time.
Okay, so bringing it back to some of your early interests in reading and literacy type skills as well.
Right. The work that I'm doing now is really interdisciplinary across those areas.
Mm-hmm. And it seems like for especially preschool-aged children, I mean, it does seem like their learning is all intertwined and a lot of things seem like they affect other things. Whereas for adults and older students, we seem to really compartmentalize the different disciplines.
It's true at the preschool level that a lot of the children's learning really happens really across domains, but it's also true at the older ages. I mean, reading and math are inherently linked throughout children's and adults' academic development.
Mm-hmm. So really maybe the compartmentalization of disciplines for older students and for adults might be sort of artificial is kind of what you're saying?
Right. We need math for science. Science helps us understand math. And same with reading. Early on we learn to read, but then we read to learn. And mathematics is one of those domains that we can read to learn.
I've been speaking with David Purpura from Purdue University about his article in AERJ called Informal Numeracy Skills, the Structure and Relations Among Numbering, Relations, and Arithmetic Operations in Preschool. And David, before I let you go, I have one more question for you, which is sort of not as scholarly of a question, but I'm just curious, if you weren't in math education and education research and psychology in general, what would you see yourself doing?
I'd probably end up being a sports reporter or something like that, or a sports writer. I absolutely just love baseball and basketball and football. I'm a big Boston sports fan, so anything that has to do with Boston sports, I'm all about it.
And have you been getting into Purdue University sports and Big Ten?
Yeah, absolutely. I was actually an undergrad here at Purdue, so it's nice to be back home and cheer on my home team.
Well, that's great. David, thanks so much for taking the time to discuss your article with us.
Thanks for having me, Sam.
Thank you for listening to this episode of the Math Ed Podcast. If you'd like to support the podcast financially, please use the PayPal donation button at mathedpodcast.com.